Good evening, ladies and gentlemen. Welcome back to CIBC Presents Entrepreneurship 101. Tonight's lecture is on product development. And I want to share a little anecdote with you before I introduce this evening's speaker. What can go wrong in product development? Well, I heard a story from a researcher at an institute, DCIEM, which is a military development institute. They have labs just up by Downsview. And they told me a story of developing a new weapon system for an infantryman or woman these days. And that consisted of some changes to the rifle, some changes to the bulletproof vest, and some changes to the helmet. And so they had a program to develop this new system, and the teams went their own ways developing the different components. And then they discovered that when they went to test the system, and I'm going to have to step away from the microphone, so I'll try and speak loudly. They discovered that when the soldier went down like this with the weapon, the jacket rode up, pushed the helmet forward down over their eyes, so that they couldn't see a damn thing. That's a classic case of a failure in product development. So tonight we're going to have a speaker who's going to tell you how not to do things like that. Okay? I'm delighted to welcome Steve Carkner. Steve is the founder and president of Panacea Medical. But I just learned Steve got an electrical engineering degree from Queen's. And the reason he didn't go to Waterloo, which was his first choice, was that he'd actually started his first company when he was 15. And he already had 6 employees. And he was based in Kingston. So he kind of had to go to Queen's to do his degree. And his company, it was in design services, and did a variety of interesting things, anti-lock brakes for motorbikes, and some clever money-making tricks on installing AutoCAD, which is a software program, a design software program that at the time came in many, many discs, and he very cleverly figured out a way to do that for a tenth the cost of anybody else, and as a student, I guess paid for his education by running his business. So he's certainly got cred as an entrepreneur starting at that early age. He moved to RIM and did some good stuff there, and then moved to found Panacea. And Panacea is, I'm going to read from the website here, designer, developer, and manufacturer of convergent, non-invasive medical devices and diagnostic instruments. And they do other things. But I think suffice it to say, Steve, and I've crossed paths with other companies that I know have been using Panacea, real expertise in taking ideas and turning them into real products. So we invited Steve to come down here and to share with you how not to do what the military did with their infantry system, and how to take your idea and efficiently convert it into a real marketable product through good product development. So, Steve, over to you.
I guess I'm on. Okay. Hello. I think I heard a really an interesting quote that I think actually sums up product development, and it's a little off color, but forgive me. Product development, I think I would describe as there's a lot of fans out there, and there's an awful lot of stuff that can hit them. So hopefully some of this tonight will just give you a little bit of an idea of how to structure things so that nothing hits your fan. Let's see here. Okay. So you've already seen, heard a little bit about my background, I guess. I've been doing product development for 20 years and was actually in charge of product development at Research in Motion and intellectual property, which the two kind of go hand in hand. As you're developing products, hopefully you're also securing them. I know that that's either was a subject or will be a subject for another lecture, though, so I'm not going into intellectual property today. And principally, I'm an electrical engineer. I think what I'm talking about today, though, it applies across anything. It doesn't matter what it is. If it's a product, even if it's a software product, these things will all apply. So a little bit about Panisys. As was mentioned, we're a medical product developer company, but we also develop products for the military and products for consumers. Right from the napkin sketch. We've had, for example, we've completed the design of a DNA analysis system where literally a doctor and a businessman came into our boardroom and they put pieces of a floppy disk drive on the desk, and we said, we think we can make this do DNA analysis. And today we're doing DNA analysis with actually something pretty close to what they put on the desk. So that's where it starts. And we've done products from little itty-bitty lights that are about this big and sell for a couple bucks at Walmart, up to huge military systems that power fighter jets. And I can tell you from experience that the difference between this little tiny light and this big power system for a military jet or DNA analysis systems, the path in product development is actually the same. There may be just a few more or few less zeros at the end of your budget. So, product development, like I said, doesn't matter how big or how small. The same basic path should be followed. And the failure to have a plan and to follow it, I would say will result in inefficiencies at the best. The best case, you're still going to get to the end, you're still going to have a product, you're going to get there inefficiently, probably take an extra year or two, but you'll get there. That's the best case. The worst case is you'll just fail. You'll run out of money, the product won't work, you'll launch it and it won't do what people expected. There's all kinds of things that can go wrong that are going to stop you dead in your tracks. But that's still not the worst case, actually. The absolute worst case is you get to the very end of the day and you get sued because you hurt somebody or there was something that was underspecified. So there is actually an even worse case than not completing your program. So, following a plan. The question, I guess, is how do you do the plan? What's involved in a product development plan? Whoop, I hit the back button, sorry. There we go. There's a lot of different models you can follow for product development. And what I hope is by giving you a few of the terms, you can go out and you can Google and learn a whole bunch more on your own, because that's the beauty of the internet today. The thing with the internet is you've got to know what you're looking for. So one model you can search on is called the V model, and I guarantee you can go out and you can do a search on the V model of product development and you'll learn a whole lot more than the basics I'm going to give you today. You could probably even search on regular product development and find other models, but this is one that I particularly like, and I think it fits well actually for the sort of research model going through all the way to production. So we start out with the concept of operations, which is essentially what can you do? What are you going to contribute to the product? To the requirements and architecture, how are you going to do it? What's required of the product? The detailed design, now that you know what you're doing, how do you get there? Actually implementing it. Most people focus on implementation. They think that's like the biggest chunk, but there's a lot to do before you get there. And the V model is very good, I think, at illustrating that half your work should be before implementation and half your work should come afterwards. So then you move up the other side of the implementation V, and you get into integration, testing, and verification, which, as it says, is putting everything together and making sure it works. Then system verification. And again, this is something that people tend to forget, is that the piece that you're doing probably isn't the start and the end. It probably goes into something else. So if you're designing something for, I don't know, a cell phone, for example, well, a cell phone has to work with a network. So the cell phone may work, but doesn't work with all the networks. That's the system verification. And finally, operations and maintenance. It's great to have something on the market, but what do you do when it fails? What do you do when the customers don't understand how to use it? So it's all that customer support. How do you make more of them? How do you stay ahead of the market? That's your operations. And at every stage, you should be verifying and looking back at those initial specifications you came up with, at those initial customer requirements documents. So we'll do a little more in-depth on these. So concept of operations. Again, what is principally the idea? Which I think you guys all have ideas, so that's usually the easy part. But understanding who wants it, understanding what's it for, who's going to pay for it, and what's your capability in the area. And that last point is probably the hardest one, because you've got to ask yourself, not just what can you do to move the product forward, but what are you good at? What are you efficient at? Because, you know, a lot of people, you think you can do everything. And, you know, if you're smart, you probably can do everything. But if you're not really good at software, for example, but you're really good at electronic design or mechanical design, trust me, leave the software to somebody else. Because you're going to be so slow and so inefficient at it, you're going to shoot yourself in the foot. So recognize what you're good at. What you're probably good at is the idea. Get help with the other stuff where you need it. The concept of operations, a lot of the information that you gather here is going to feed into the requirements in the architecture document. And this is generally broken into four documents. The first two are the absolute most important. And I've seen many, many, many products where they don't even exist. Or they exist in somebody's head. The first one is the customer and market requirements document. And it should not be technical. It should be about what do people want? What does the market want? So, you know, don't talk about storage, you know, an MP3 player. Don't talk about storage requirements. You need to talk in terms of, you know, they want more space for their music. Not they want 8 gigabytes of, you know. No. This is just what do the customers want in your product. So that's your customer and your marketing requirements document. The next one is the functional requirements, which is a little more technical, but you should still try to avoid talking about how something's going to be done, how something's going to be implemented. And the reason is because you shouldn't be the person who's doing all of that, and you shouldn't be the expert in doing all of that. So the object of these first two documents is to give you something that you can take to other people, that you can take to a team, and that you can say, this is what we want. How do you think we should do it? Let them decide the best approach. Because if they're an expert in software, they're going to know the right way to approach a software problem. And the more constraints you try to put on that through, you know, throwing in technical details, the more likely the product is to be just plain wrong, or bloated, or doesn't fit, or 3 years out of date. Okay? So, customer market requirements document, functional requirements, very important. I'm going to refer back to the example that was just given to you at the start by Tony about the jacket and the helmet and the rifle. So, you had a case where each individual item was likely specified to death. I mean, this is a military thing. So, you know that there were lots and lots and lots of specifications around the helmet, the jacket, and the rifle. What likely did not exist was essentially a customer market requirements document that said, we need a jacket and a helmet and a rifle for a soldier to wear at the same time. Right? I mean, at that point, that problem wouldn't have occurred. And the worst time for that problem to occur is right when it occurred. At the very, very end. You're in production. That's when the problem occurred. So once you've got those first two documents, then you get into the product and engineering specification. That's where you get technical, and that should be produced by a team. So that's when you start talking about exactly, how fast does a processor need to be? How big does a mechanical thing have to be? Does an elephant stand on it, or is this going to be perched on a desk and never touched? So now you can start getting into a lot more technical information about exactly how something is to be done. And it should be technical enough that pieces, when they come together, they actually mesh properly. So that's a document that you might want to break apart and give to separate people. The next one goes with it is the test and verification spec. It's not good enough to just say this is what you want. You've got to say how you're going to test it. And quite often when you're doing the test and verification, it's going to highlight a lot of deficiencies not only in the product engineering specs, because you're suddenly going to go, oh wait, geez, I hadn't thought about, that particular interaction, but you're also going to be referring back to the functional requirements and to the customer market requirements. That test and verification spec would be where you say, this is how we're going to test the jacket and the gun and the helmet. We're going to test those, and we're going to test them on soldiers, and we're going to test them on female soldiers and male soldiers and people of different heights. And now you've got something that you can test against and you can prove it's going to work. And you're doing it, hopefully, before any design has started. Nobody's actually started building anything yet. And now we know where we're going. Of course, hindsight's always 20/20, right? There's going to be all kinds of stuff you forget. We all do that. So that's where the bottom one comes from. The issues you find during the design phase will most likely change the technical documents, but they shouldn't change the customer and the functional requirements. Design should never dictate what the market wants. The market, the people, they're going to tell you what they want. Don't let technical things dictate what you build, because what you'll end up with is an engineer's dream that doesn't sell. Great. What did I do with it? I'm always putting stuff in my pockets. So then we move into the detailed design. So hopefully at this point we've got a document that says what we want the product to do. We know what the customer wants. Let's go. Detailed design. So now this is the most common thing that you're going to break apart and outsource to people. Again, unless your product's really, really tiny, you're not going to do it all yourself. So you want really, really well-written, complete requirements, architecture documents, something that simplifies this step because everybody's on the same page. And it's so tempting at this stage to just sit down with a couple people and to talk about what you're looking for and send everybody off and kind of, do the specs as you go. If you do that, you're going to spin and spin and spin and spin, and 2 years later you're going to find that you're not really very far along. So, again, this is the time to make sure to have those requirements docs. And sorry that I keep talking about documents. I know it's boring, but it's, fact of life. It does make things go faster in the end. The larger the programs, the more you break them up, the more you're going to be assigning a whole bunch of different people. You're going to end up with a mixture of in-house, outsourced, people validating each other. So this is where you do see a difference between big programs and little programs. But fundamentally, you should still have that same document set. They just get bigger and more complicated. And the last point, always keep an eye on those customer requirements. Ensure that the design decisions that you're making don't impact them. So this is a case, well, I'll use an MP3 player again, So the engineer might say, oh, we can't address as much memory as we thought we'd need, so we're just going to cut the memory in half. Well, okay, that may be a great engineering solution, but if the customer was looking for an hour of music and now they only get half an hour, well, you've just blown your customer requirements, right? So again, you got to keep your eye on that customer requirements. Feature creep can also be a problem because engineers love to say, hey, let's put 4 times the memory in. Well, maybe there's a customer requirement about battery life. You put 4 times the memory in, you think you're adding a feature, but you just damaged another feature and now you've blown your customer requirements again. So always refer back to those customer requirements. They'll guide you and they'll make sure that you design the right product without over-designing and under-designing in certain areas. Finally, we're at the fun part, implementation. So now you know what you're building, now you get to build it, you get to write the software, you get to mix the chemicals. Your specifications should have broken things down into smaller chunks, so now you can actually build things into smaller pieces, you can validate them in smaller pieces, and have pretty good confidence that all these little tiny pieces at the end are all going to fit together. If you're bringing in contractors, this is the most likely place where the contractors are going to start actually billing you. Up to this point, you can probably get free consultation from a lot of your contractors because you're going to be trying to identify what they're going to do. And so that's part of hopefully a quoting process where you can say, help me out here. Let's define what you're going to do, and then you can tell me how much it's going to cost. So this is the point where you should have a really clear statement of work for them. Tell them exactly what you want from them, what you want them to do. That will prevent either having them take on too much and then all of a sudden you get bigger bills than you expected, or the opposite, which is where you get something delivered to you and you find out that, oh shit, it's only about half of what you actually expected and you're not capable of putting the rest in. So a detailed statement of work is going to help you and whoever it is that you're contracting to. And again, departure from the specifications. You're going to come up against all kinds of hurdles where you're going to have to change the specifications. Don't do it on the fly. It's so tempting. Oh, it's just a tweak. It's just a minor change. It's so tempting to make changes on the fly, and it will come back to bite you. So again, refer back to the statement of work you've done. Refer back to your specifications and change them if you need to. Because when you start getting, the first one or two, it seems like not too big a deal. When you get into 20, 30, 40 of these changes, you're going to lose track, and you're going to lose track of all the interactions. And somebody is going to make an assumption that the spec is being followed. And when you plug the two things together at the end, they won't go. Because two people over here made an on-the-fly decision, and this person over here didn't know about it. And the whole thing breaks. And it breaks at the most expensive time, which we're going to get to when you start integrating everything together. So update the specs, document what you do. And a suggestion I have as well at this point is to create a tracking system. And this helps your team a lot. Every time you run into something. So over here I've got, for example, and this is just a spreadsheet. There's actually software you can buy that does this, but let's face it, spreadsheets are great, they work, they're cheap. So over here, description. Customer specification does not explain what the charge enable signal is used for, or if it can be ignored. We plan to ignore it. This is real, by the way. This is actually out of a real project. So, how fixed? Well, this is being clarified. The signal is an absolute requirement. So, we went back to the customer. The customer said, no, we'll explain it. We didn't explain it, we'll explain it now. It is necessary. So they explained why it was needed. We added a second processor to handle it. We've closed it. This was, when it was opened, who opened it, who closed it, when they closed it. It's really easy now. Before you start, burning silicon or releasing software or whatever, before you get to a stage where you're committing yourself to production, you can refer back to this. Oh, look, closed, 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 closed. Oh, there's an item that's open. Did we address that item? And if you open something like this up to everybody on your team, I even open these up to customers. If a customer calls us and says, what if, or, I've experienced something, we throw it right in here. And we don't release the next revision of the product. We don't release a major change unless we've got every single one of these closed, or at least we've made a, decision about why we're not closing it. So simple tracking keeps everybody on the same page. And now we start getting into the expensive stuff, where we're going to take all these little bits and pieces that all these different people have done, and we're going to start plugging them together and crossing our fingers and hoping it all works. So we're collecting. We're collecting all these bits and pieces. And my experience has been that this stage is usually under budgeted or completely ignored. My experience has been that this stage costs more than the entire integration stage, and usually most of the definition stage as well. This stage will double your budget, and yet most people don't even budget for it, because there's an assumption that, well, we followed the spec, we built the stuff, it should work. Couple days, and we'll have this thing up and running. 6 months later, you're still beating your head against the wall because stuff gets missed. We're all human. So budget for this. If it's your first program, budget a lot. The more programs you do, yeah, maybe it goes down. Hasn't been my experience. Sadly, it hasn't been my experience. So collect everything together. Make sure you've budgeted for this stage. And budgeting isn't just money either. And I'm sure you guys have had, I think you've already had the lecture about budgeting and money and finances and funding. Budgeting is about more than money. Budgeting is about time, but budgeting is also about people. And I sometimes talk about companies being resource bankrupt. And it's probably not a term you've heard very often, but again, you can Google it. Resource bankruptcy is when you run out of people. And it's very common in this stage to run out of people. And you know, a company can have financing, a company can have customers, and they can still fail because they don't have people, or the right people, or enough people. So make sure you've left ample time for this stage. So you pull all the modules together, all the work is brought together, you plug it in, and hopefully you get to the end of this stage and you've got something that's kind of all together and is working, and you've got a thing. But it won't work the first time. Most of the problems you're going to encounter here are going to be technical. And it's different from the next stage. So you're going to find that here it's the technical stuff. You know, parts, there was a decimal missing on the part or something, so you know, mechanical things don't plug together. Electrical things, you have connectors swapped, that type of thing. It's going to tend to be of a technical nature, stopping stuff from plugging together. Again, resist temptation to fix on the fly, fix the spec, revise the statement of work, move forward again. If you do that, you'll only fix it once. If you don't revise the spec, guaranteed you'll fix it again. And you may even fix it and then have it break and then fix it again and have it break again. Because people will keep going back to the spec and they'll keep doing it wrong. And it's not good. So fix it once. Now you get into your system verification. So now you're kind of looking back on not only the technical details of the product, but you're looking back all the way back to that customer spec. And you're starting to look at how the thing is used. So maybe, again, the military idea, you know, your company built the jacket. This is where you're testing it with the helmet and with the rifle. And if you've done your job right, everything works properly. So if you do experience problems in this area, it's rarely technical. It's usually application related. It's usually customer related. And quite often when you get to this point, it's actually your customer who is wrong. And that can be frustrating. And you know, the best way to get around that is to, you know, keep your customer in the loop, show them your prototypes, you know, keep them engaged throughout the development process. But really, a lot of the times here, you find out your customer was wrong. They didn't realize what they were asking for. They didn't understand the cost implications or the weight implications or some other implications of what they were asking for until they see the thing. You see this a lot actually in mechanical designs where you're doing a sexy product. And you hand it to the customer and they go, oh, geez, it looked a lot smaller in the pictures. Kind of late. Kind of late. That's the unexpected operation or interactions, that sort of, whoa. And you see the shock and you know you're in trouble. You want to have this detailed system verification plan. And part of the reason you want it, or design validation plan, part of the reason you want it is not just for this stage, but because when you're doing all your design work and your implementation work, you're going to actually look forward at it. How am I going to pass that particular thing? I know it's coming. It's in this, it's in this system verification plan. And it allows people to start testing before the end. So, for example, if you have a product, actually there's a good example. So you have a customer who says that they want a system to operate at a 1,000-watt pump. Well, that's great. If you know that there's a 1,000-watt test in your plan, you can test for it before you get there. So now you've got something you can test against before the whole thing's assembled. Looking forward, the problem, of course, is if the customer was wrong and it turns out their pump is actually 3,000 watts. Like I say, sometimes the customer is wrong and you deal with that as best you can. Of course, if we would have had a pump, we could have tested the pump beforehand, and that's always a good thing to ask as well. Treat failures like they're gold. This is something that I try to impress really hard on my employees and even on my customers. Again, it's something that tends to get missed. If you're building your first 10 prototypes and one of them doesn't work, what do? We say, that's a prototype. 9 of them work, that's pretty good. And you put that one failure aside because you know it's just a prototype. Guarantee you, that one that failed has some flaw in it that's going to show up in 10% of your production units, and you just threw it away. So treat your failures like gold, get to the root cause. And maybe it is just because it's a prototype and there was a pin not soldered or a bit flipped or something that in your software. Maybe it was just because it was a prototype. But what if it's not? So anytime you get a failure, especially at this stage where you're into that little volume, you've done your integration, you're starting to produce some product, treat it like gold. The products will fail. They'll fail in ways you have like no concept of when you're starting or doing the product. You have no idea. The stuff fails and you go, wow, geez, I never thought of that. I never thought it would do that. And it does. So treat it like gold. Treat the prototypes like gold when they fail. I think a failed prototype is far more important than one that works. I mean, the 9 that work are nice, but that one that failed, that's the one I'm most interested in because it's a predictor of what's going to fail in production. And now you've produced your prototypes, you've got it working, now it's time to get into the operations and maintenance. All those documents you did, they weren't just wasted, they weren't a time waster, they weren't bloating the thing because they're going to come back to play a part here now. Because presumably you're not going to build, I don't know, 1 million pieces of something in your basement. This is the time when you're going to be looking at contract manufacturing or ramping up, hiring 1,000 employees. So your day-to-day activities start, you've got a product. Well, how do you test it in production? How do you make sure that the parts haven't changed, that you haven't got fake components? Happened to me. We've had fake components, put it in the part starts to smoke and you don't know why. Fake component. So all those verification documents and design specs and everything else you did, they're going to define what the product should continue to be moving forward. And they're going to provide the baseline for your production testing. So you're going to come up with things like this production test plan at the bottom here. That's your basis for not only testing stuff that goes out the door, but even testing stuff that goes back. Again, how do you handle failure? Because you're going to have failure. Production test plans based on the spec, based on what the customer wanted, is a great way when a failure comes back, slap it right back into your production test bed. Does it still do what it did when it left? And sometimes it does, and that's really telling. Because now you've just shown that your production test system is broken. Because the product didn't do what it was meant to do, and yet it passes. So all of those documents, all that stuff you built, it comes back into play here in the operations and maintenance. At this point, I hope you've won. If you define winning as launching the product and making money, at this point you've won, but you can't ignore this stage either. And you can't just hand it off to somebody else without all the supporting documents. And we get into the next revision, and this is where all those arrows that went back across the V come into play. So it's normal to go to revision 2. Look at it as an opportunity. So there's far too much focus, I think, on getting everything right the first time. On that first product is going to come out and we're going to sell thousands of them. Rarely happens. Your revision 2 is when you're going to sell thousands of them if you listen to the market, if you take all that feedback you gather, and understand what you need to change. Don't get started on revision 2 too early. Don't try to keep modifying what you're doing. It's better to just get it out there, do everything at once, do a revision 2. Don't do all these little incrementals. So go to revision 2. It's not a failure. Everybody does it. Yeah, and you may even make more money by doing it because there's always this tendency to add lots and lots and lots of features. At this stage, you'll know which features are actually going to make you more money and which features just don't pay for themselves. So allow for some feature creep. Tools. I'm going to go over now just a few tools that you can use. That's sort of the basics of how I see product development. A few tools that can help you out. One of them is the Gantt chart, and I know this is pretty basic for some of you, but some of you, maybe the first time you've seen one of these things. Basically, with the Gantt charts, and these are the core of product development, you put what your task is. You can have them all in a nice hierarchy, and the hierarchies are great for explaining what's physical and what's software and what's electrical and chemical, and so you can divide everything up, figure out approximately how many days it's going to take, map out all the interdependencies between them, and you can even assign resources. These tools are great. Microsoft does one. Microsoft Project is probably the most common one that people use, but there's tons of these things out there, and there's a lot of them that are really specialized. If you're in the chemical field, there's chemical project management tools. They're really, really specialized. They even have them for law firms, have project management tools now. Fantastic. And you can actually plug in your resources, plug in your time, and at the end you can say, well, okay, how much time does this thing take? Where's my critical path, and how much will it cost? And they're pretty accurate. My only criticism of them is that it's very easy to get into micromanagement. It's very easy to get into just tweaking every little parameter to death. So don't get into micromanagement with them. Mapping out the critical path through your project and then squeezing it down, not a good use of this tool, because you'll squeeze it down to the point where there's no fat left in the schedule. So use it for what it's good for, which is organizing your tasks, organizing your project, and understanding the interdependencies. That's the best use of this tool. The other stuff comes along for the ride, I think. Another tool, which is called the gate review process. It's kind of like the V model, but it's a different way of doing it. The military really likes this, and you can actually use both at once. We have projects where we use both at once. And this is I think a little bit simpler model, so I thought I'd introduce it to you as well. Basically, you start off with an opportunity assessment over here, and you have a gate. And that's why it's called a gate review, because you have all these gates in between the opportunity, the planning, the design, the qualification, limited production, and full production. You have all these gates. And the idea behind the gates is that it's a chance to pull together the team, and the team should include your finance people and everybody, so that at the start of the project, you have a full budget. Define your budget in terms of the gates. Define your timeline in terms of the gates. Define your deliverables in terms of the gates. And now, once you've done, say you've gotten through, your design. So you come to gate number 2 at the end of your design phase. It's a great time to sit down and say, are we on track? What failed? Where are we? Did we screw up big time? That's the advantage of the phase gate. Quite often, the customer will be brought in on the gates as well, the gate reviews. So, in the military, they often have test reports and things that they expect as well at those gates. So, this is another tool if you want something a little simpler. You can try the gate phase process. Budgeting for development. So this is not. I don't want to tell you how to budget so much as just to give you an idea of some of the pitfalls. First of all, it's not always a bad thing to be over budget, which is good, because almost everything ends up over budget. Every project should have some spin. You should have some inefficiency in there, because if you stick to exactly the letter of the law, it doesn't allow for any creativity. It doesn't allow for those sort of leaps of faith that really produce great products. So allow for a little bit of spin. Don't be too concerned if you're a bit over budget. And again, remember, budget can refer to people, time, as well as money. What I want to caution you on, though, is who's responsible for it. And especially if you're the sole person responsible, or if there's principally one person responsible for the budget, I think the fewer people who are involved, the further off you're going to be. And seriously, if it's just you doing a budget, you're going to be off by an order of magnitude. You're going to assume that stuff is simpler than it really is, than the experts will tell you it is. Probably will underestimate test time, will assume that stuff goes together properly. There's all kinds of things that you'll get wrong. And it's just because we as humans tend to be overly optimistic, I think, about our own abilities. So be realistic, get a second opinion. If it's your first project, double their opinion, and you might be in the ballpark. And literally, some of these programs, like I have people come to me and tell me that they think something should take a few weeks, and I look at it and I'm able to say, guys, you're going to be 2 years. And sometimes those customers walk, and I'm not that surprised when a year and a half later they come back and say, okay, can you guys start on it now? You know, because they just spun and spun and spun for a year and a half. So get a second opinion. Don't be afraid of overestimating a budget. It'll never happen. I've never seen anybody overestimate a budget, ever. Look for similar products. And you know, it's probably not as hard as you think to find similar products. You can do an internet search on a product that's close to whatever you're doing. If you search around, you can often find companies that have put those in their portfolios and said, hey, you know, look at the cool thing we did for one of our customers. Ah, cool. Now you can contact them and say, you know, approximately how long did that take you? You can learn so much by doing that. And some of the answers are really going to surprise you. You can also figure out costs on, for example, engineering time. A huge engineering company with tens of thousands of employees recently announced that they were laying off 2,000 workers. And they also announced how much money it would save. You could actually do the division and go, oh, cool. Their engineering time cost $900 a day. Worked out perfectly. And that's about right. So, you know, dig around. You can find out how much stuff should cost by comparing to other stuff that's already out there. And again, I think you'll find that it's probably 5 or 10 times more than what you're expecting. But that's okay. That's what VCs and money raisers and, well, Mars is here for, is to help us understand that and to help us hopefully finance it and find the right people to help us out. Finally, don't expect to beat the predictions just because you're small. There's, again, this feeling that, well, it's just 3 of us or 2 of us. So we're going to be way more efficient and faster and we're cheap. And yeah, if you're working for free, maybe, but that's not sustainable. Ultimately, it's going to be pretty much the same cost whether you go with a big company. A big company is going to charge you more per day, but they're going to be way better at it. A small company is going to charge you less per day, but they're probably going to take longer. And at the end of the day, you're going to spend the same. And if you go with somebody in their basement, they're probably going to be the cheapest you can find is the guy that works in his basement. But then you're going to have a lot of design revisions and you're going to, you know, have some problems there. So again, you're probably going to be right back to the same cost. So just bear that in mind. And that, I think, leads us into choosing a partner. Again, you're not going to do it all yourself. So at some point, you're going to have to choose to work with somebody, a person, a company, to build your team and to build out your org chart. So remember when you're doing that, that these people are going to be directly responsible for the success of your idea. So this isn't the time to go for the lowest bidder. This is the time to say, who has the right experience in my area so I can do it right. So I can do it right the first time, because time is money, and you know, being a year late on delivering a product probably means you've missed your market window. So it's not the time to cut corners. It's the time to be very, very careful. And that may still mean the guy in the basement is the best choice for you. I don't know. It may mean that the huge company of 10,000 people is the right choice for you. Bear in mind as well that if you are looking for money, investors are getting really skeptical about completely outsourced models. It was all the rage a few years ago. They loved this whole, hey, we're going to outsource everything. They're getting skeptical of that because I think investors are starting to understand that when you outsource everything, you lose knowledge. And there has to be a core. There has to be a core of knowledge inside the company. Otherwise, you have no control. You know, you outsource something to a big design firm, and then 6 months later you need to do a tweak or a revision, and the person that did the work, well, you don't even know who they are. Or if you do know who they are, they've moved on and they're with another company or they're working on another project. So you need to either keep some of that knowledge in-house or convince your investors that the people who you're doing work with are really a partner and are going to be around tomorrow. If you do it right, you're going to find a partner that's going to actually add to your company's reputation. You're going to be able to piggyback on top of their reputation for delivering, and your investors are going to appreciate that, and they're going to look at them as being part of your org chart. So when you say, this is who's doing my product development, and this is who's doing my manufacturing, and this is who's doing my approvals with the government, they're going to nod and say, yeah, you've made good choices there. And again, could be people, could be companies. Don't know. Check the references. And companies will give you references, and that's fine. You should definitely check the references you're given. It's not embarrassing. It's not that you don't trust them. It's that you're being careful. And I have heard people say that. I've said, did you check my references? Well, no, I didn't really want to. Why? Don't be embarrassed. Go out and ask. And look for your own. Because the company's not going to give you the name of the customer they pissed off. They're only going to give you the name of the customers who are really happy, right? So again, that's where the internet search is wonderful. Find out who did the work, track them down, and you'll get some honest answers. And if you go in, they might still be a great partner, but at least you're going to go in with your head up. And it works both ways. Be open. Be open with the company that's doing the work for you. Let them know your status. Let them know where you're at. A good example of that, for example, is with finances. If you go in and say, oh, we're going to raise millions of dollars, well, then don't expect the company that's doing the work for you to, kind of scrounge and try and save you money, because they don't realize it's even an issue at that point, right? So you want to be open with them, let them know where you stand. Hey, find out if they can help you. Network with them. Make them your partner. And I think you'll do a lot better doing that. And they'll be there when things don't go to plan, because things never go to plan. Finally, contracts. Just going to touch on contracts. And again, not the mechanics of it so much as what you should bear in mind when you're getting into these things. I like to say that business should always be done on a handshake. If you don't trust the company or the people enough to do business on a handshake, then there's no point in doing a contract. Because, trust, hey, the contract is just a piece of paper at the end of the day. And, you're probably not in a position where you're going to, press a contract against somebody. So if you're not willing to do business on a handshake with somebody, don't move to the next step. The other thing is you don't have to jump straight to the contract. So my suggestion is you do your business on a handshake, you follow it up with a memorandum of understanding. And that's just a bullet list. So you say, hey, we met on this day, and we agreed to these things. Do you agree? Wonderful. Now you can go to your lawyer, and you can say, hey, we've agreed on all this stuff. Put it into a contract for me. You just cut your legal fees probably half, maybe more, because your lawyer knows exactly what you want. Enough of the details are already there. So do your handshake, memorandum of understanding, follow it up with your contract, get your lawyer involved. And a well-written contract is going to benefit you both, and not just in a legal sense. A lot of people, you sign the contract, you put it aside, and you ignore it. You probably refer back to that contract. You'll probably come back to it and say, what was that royalty we agreed to, or what was that timeline, or what was that daily rate, or geez, they're getting kind of behind. Didn't we have something in the contract that covered us in the case that we were late or they were late? So, it's going to benefit both parties because it gives you a common ground. Guaranteed, if it's not in the contract, you're going to come back a year from now and you're going to be surprised because you're going to say, well, we said, and they're not going to remember it that way at all. And I see that again and again and again, and boy, it's nice to be able to pull out a piece of paper and say, you know what, this is what we agreed to. And I'm not trying to be a jerk, but this is what we agreed to. And it's funny how often the person goes, ooh, oh yeah, now I remember. Good, glad you remember now. Let's move on. So that's it. Hope I didn't bore you too much.